pretty easy, guys. You gotta remember this. So, area of a shaded region just means I'm only taking an area of a section of the circle. Now notice, I didn't draw this perfectly, but this is a central angle opening up on an arc. So we know that, okay, the area of a section, an area of a circle is pi, an area of a full circle is pi r squared, right? So area of a section of the circle is the section out of the circle times pi r squared, right? Now, keep in mind, if this is already written in radians, you do need to use the other formula, which is, because this is technically theta over 180 times 2, correct? Yeah. Times pi r squared. So let's say that this degree right here was in radians already, then you've got to cancel those out and plug it in to that formula. Does that make sense? Because in the formula is the conversion for us, in this formula. Does everybody get what I'm saying? Yes. So this one's in degrees. So we want 120 divided by 360, that area. And then our radius is 5 centimeters squared. So what did we get? What's the math answer? You guys say 25 pi over 3. Okay, centimeters, square centimeters. So that's the area that's covering, like the actual area of centimeters. So then an engineer would want the decimal answer. So what was that? 26 point. Okay, awesome. Centimeters squared. Okay, awesome. You guys are great. Thank you. All right, sweet. Okay, so this is considered 6-2, even though in the book it's not going to be 6-2. In the book we're going to be on page 299. So this is 6-2 and it's going to be the unit circle. So consider the circle given by this equation, x squared plus y squared equals 1. Recall that equations of a circle look like this, x squared plus y squared equals 1. So equations of a circle, just a reminder, are of this form. X minus h squared plus y minus k squared equals our radius squared. So if we had this equation, there would be no shift left and right, no shift up and down, and our radius would be 1. So consider that circle, I graphed it right here. Does everybody see how I graphed that circle? X squared plus y squared equals 1, a radius of 1. Now what we're going to do is we're going to zoom in on that. Zoom in, zoom in, zoom in, and there we are. So here we are focusing in on that. Everybody good? So wouldn't this be over 1 of 0? We zoomed in. Over 1 of 0. This is over 0 of 1, negative 1 of 0, and negative 1 of 0. And this should be fixed. Over 0, down 1. All right, so over 0, down 1. Okay, so now imagine, instead of having it all laid out like this, imagine that if we zoom in on this, imagine that the real number line is wrapped around this circle. So it's wrapped around the circle, and positive numbers would be going counterclockwise, and negative numbers would be going clockwise. So imagine the real number line, instead of being spread out, is actually wrapped around that. Okay, so as the real number line is wrapped around a unit circle, each real number will correspond to an xy point on the circle. So everybody, if this is the real number line wrapped around this unit circle with radius of 1, then each point will correspond to a real number, correct everybody? So this is an xy point on the circle. Now also will correspond to a central angle theta. So obviously if I open up to that xy point right there, that's going to be, this theta is opening up to that point. Is everybody good with that? Okay. Now these are, you'll want to write these down, and we're going to explain where these come from in just a second. So just right now, write them down, and then I'll explain where they come from. So these are the xy definitions of trig functions that we're going to use in this unit, and I'll show you where they come from in just a second. So these are going to be things you need to have memorized, and it'll be pretty easy for you once you see them and we start practicing them. So sine of theta is going to be our y value of our xy point. So if we're looking at xy points, and we will be looking at xy points, if I say you find sine of this angle, all you have to do is look at y. So sine of theta equals y, the y value of an xy point on the unit circle. And our cosine of theta, cosine of the angle, is just going to be your x value. So if we have an xy point, and I say to you, what's cosine? You'll just tell me it's the x value. So cosine of theta equals x. And then tangent of theta equals y divided by x. You take your y value, you'll divide it by your x value at that xy point. That would be tangent. Then cosecant is the reciprocal of sine, so we flip it over 1. So cosecant is 1 over y, secant is 1 over x, and tangent is y, x over y. Holy cow, I was not focused when I made this smartboard. So cotangent, what the heck? What was I doing? Well, I'll have that fixed for B-Day. Cotangent is x over y. I have no idea. Like, I don't even know what I was doing when I wrote that. All right, does everybody have those written down? Okay, we're going to tell you where those come from. So everybody, flashback to right triangle trig. We have learned right triangle trig. So everybody listen. Here's our unit circle. We zoomed in on 1, right, with a radius of 1. Everybody, aren't right triangles? We know right triangle trig. Sine of theta is opposite over hypotenuse, true? Cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. So look at my unit circle here. We have a radius of 1, and we have this angle theta. Well, isn't this side length of x over to here? So if I have this xy point, if I go up and have this xy point, I'm going to drop down and make a right triangle. Is everybody good up to there? Okay, now here that was created from angle theta. So now here's theta, here's on our opposite side, here's my adjacent side, and here's my hypotenuse, which we know if the radius is 1 here, then our radius is 1 right here as well. So here's our right triangle. So think about it, guys. If this is over x of y, wouldn't this distance from here to here on our triangle be x? Yeah. And then this distance from here to here would be our y value, correct? Okay. So sine of theta is opposite over hypotenuse. So sine of theta equals opposite, which is our y value, over our hypotenuse, which is 1. So do you guys see why, just a second ago when I said sine of theta equals y, why that is? Okay, awesome. Then cosine of theta is adjacent over hypotenuse. Cosine is adjacent, which is x, over hypotenuse, which is 1. So that's why cosine of theta equals x. Sorry, and sine was y. And then tangent of theta is opposite over adjacent. So from here, opposite is y, adjacent is x. So that's why we just said a second ago that tangent of theta equals y over x. Because we're just dealing with a bunch of right triangles, okay? So basically though, if we're just dealing with right triangles, this right triangle trig, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, you're only dealing with positive angles, thetas that are positive. So what happens when we have negative angles? Like, for example, negative theta. Well, then all of a sudden, you can't have a triangle with a negative angle, correct? So the unit circle allows us to extend our definition of right triangles, because we know that sine of theta is y, cosine of theta is x. So the unit circle allows us to extend our definition of right triangle trig to use on other degrees that are not just in quadrant 1, that are just not positive. Does that make sense? So now we can find the sine of a negative angle, everybody. Does everybody see what I'm saying? Now we can find cosine of negative angles. Is everybody seeing what I'm saying? And then also think about this. We can't have a 90-degree triangle with two 90 degrees, correct? The sum of all three angles of a triangle add up to be 180. So you can't have two 90s, then you couldn't have another angle. Does that make sense, everybody? So once again, the unit circle allows us to find sine, cosine, and tangent of all angles, not just right triangle stuff. Does that make sense, everybody? Because it is just an extension of right triangle trig. Because now we know that sine of theta will be y, cosine of theta will be x, and tangent of theta will be y over x. And then we know they're reciprocal. Pretty cool. Okay, here's the unit circle. So the unit circle is showing commonly used angles. These values for x, y come from our special right triangles. So I just want us to focus in on a couple special right triangles. So if we go up, here's an xy point, here's another xy point, here's another xy point. So this was created by going up and at our 30-degree angle, that xy point. Now this was going up, this point was created by a 45-degree angle, so from there was 45 degrees. And then this was created from creating a 60-degree angle. Now these are just right triangles because we could drop down, we just talked about, we could drop down and create a bunch of right triangles here. And then we could figure out, since we know the radius is always 1, we could go through, and since we know the relationships of right triangles, we could figure out all their xy points. And I'm going to go into more detail with that in a second. I'm going to show you how this is working. So just kind of interesting. And we're going to go through, you don't even need to fill in your unit circle yet. Like right now I'm trying to help you understand where the unit circle comes from. So right now you're not filling in the unit circle. I'm going to show you how to fill that in with a trick that makes it really easy, okay? So right now I'm just showing you where these, that on this unit circle, aren't there a lot of other angles besides 30 degrees? And 45 and 60, yes. So these are just the special right triangle stuff. So these are just commonly used angles. Okay, everybody just consider if we have a 45, 45, 90 degree triangle. So 45 degrees, 45. Let's say that this side's 7 and this side's 7. Then we know that right triangles say that that would be 7 squared plus 7 squared equals the hypotenuse squared, correct? So equals, and let's say we didn't know the hypotenuse, so question mark squared. Then that would be 49 plus 49 equals question mark squared, correct? Is everybody good? So what is that? It's 49 plus 49. So we have 98 is equal to question mark squared, so we would square root 98, which simplifies to be 49 times 2, 7 times 7. So this simplifies to be our hypotenuse square, simplifies to be the square root 7 square roots of 2. Okay, everybody good with that? So that's going to happen if you have a 45, 45, then this and this will be equal, and then this hypotenuse will be that square root of 2. Is everybody good with that? You should have learned that in secondary too, first of all. You should have spent a lot of time on this. So, all right, awesome. So I'm going to erase this for a second. So this is a special right triangle. This is the relationship that happens for a 45, 45, 90 degree triangle. X square roots of 2. So let's look at our unit circle, back to our unit circle, so I can show you where these values are coming from. So look back at our unit circle. If I create a 45 degree angle, I'm going to hit this point, we drop down, make a right triangle. Now we know for a fact, no matter where I draw my radius, it's 1. So this distance from here to here is 1. Is everybody seeing that? Yeah. Well, if that's true, then we know that we have a triangle with this being 1, correct? Sorry, I shouldn't have done that one. With this being 1, and here's our 90 degrees. Now think about it. This is an X and a Y point, true? X, Y. Well, because it's a 45, 45, aren't X and Y going to be the same? If this is 45, then this is 45, then we know that these are the same, correct? So I'm just going to erase Y and call it X, because those are the same value. So let's use algebra to solve for X. So we have X squared plus X squared equals 1 squared. Isn't that my true statement? So we have 2x squared equals 1, so we'll divide by 2, correct? So we have x squared equal to 1/2, then we'll square root both sides. So we have x is equal to the square root of 1, which is 1, over the square root of 2. Now that is my answer, but it's considered not rationalized or not simplified because we've got to rationalize the denominator. Hold on, anyway. So continuing, now our last step is just to make that in the correct form. So square root of 2 over square root of 2. So our answer is x is equal to the square root of 2 over 2, correct? So everybody look, ding, 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 ding. I'm going to go back up here. Notice, we know that in our 45, 45, if our hypotenuse is 1, this is the square root of 2 over 2, and this is the square root of 2 over 2, correct? So we know that from here to here is the square root of 2 over 2, and up the square root of 2 over 2. Does everybody see? X, Y. So that's where I get that point from. Cool, right, everybody? Because this is square root of 2 over 2. That's an x point, right? And this is square root of 2 over 2. So if this must be over that, up that, right? That's our xy point. Everybody see where that's coming from? Okay, so that's where that point came from. So now if I said to you, find the sine and cosine, we can just look at the answers. If I said find the sine of 45 degrees, we could just use this instead of doing this. The sine of 45 degrees is y, which is square root of 2 over 2. Does everybody see? Instead of using right triangle trig, we could use the unit circle now. Okay, let's look at a 30, 60, 90 degree special right triangle. So just recall, this is the relationship you see. We're not going to get into why. You should have done that in secondary too. But we have a 30, 60, 90. So what happens is if this side, if our hypotenuse is 30, like if my hypotenuse is a certain length, across from the 30 degree angle will be half that amount. So if this is 30, this is 15. And then across from our 60 will be that square roots of 3. That other side, square roots of 3. So this is the relationship on a 30, 60, 90. So if we have create a 30 degree right triangle, then we know our radius is, our radius is 1, so our hypotenuse is 1. Correct? So this will be half that amount, correct? Yeah. So across from the 30 is going to be half that amount. So right here's a half. So that's up a half. That's a y value, correct? Yes. And then we know that this will be, so if you think about it, we would be dividing by the square root of 3. 1 divided by the square root of 3. 2, sorry. What would it be? 2? Right, 1/2 root 3. Yep, it'll be that amount and then root 3. So this will be 1/2 times the square root of 3. Good. So isn't that the square root of 3 over 2? So that's an x, y point. So then our x value is square root of 3 over 2. Our y value is a half. So that gives us that x, y point. So now instead of using right triangle trig, if I said to you, find the sine of 30 degrees, instead of doing opposite over hypotenuse, you could just use the unit circle. You would say sine is y, so it's 1/2. Does everybody see how you can now use the unit circle for a right triangle trig? And it's useful now because now we can find sine, cosine, and tangent of negative angles and bigger angles. Does everybody see? Yeah. Sweet. Okay, sweet. Okay, here we go. Here is the unit circle. So using xy coordinates, you can easily evaluate trig functions of common angle values. You should study and learn these exact values so you can perform calculations quickly. You're going to have this unit circle like memorized, but I'm going to give you a trick to fill it out. And really, once you know quadrant 1, you know the rest of it. So I'm going to show you a trick on how to fill this out. You're going to need to have these memorized, really, in calculus. It'll be so useful, like right away when if I say to you, find the cosine of pi thirds, you'll say 1/2, because you're going to have this memorized. Does that make sense? So just a reminder, sine of theta is y, cosine of theta is x. And then tangent of theta is y over x. So I just want to show you how the unit circle works. Look up here, everybody. These are a bunch of x, y points. Look how easy this makes it to evaluate exact values. So if I said to you, find sine of 60 degrees, locate 60 degrees. Sine is y, correct? So the exact value is the square root of 3 over 2. You see how easy that was? Now if I said to you, find cosine of 240 degrees. Now we go around, find 240 degrees. Cosine is x, so our answer, our exact value would be -1/2. And then if I say to you, find tangent of -30 degrees, you would say to yourself, okay, well tangent is y over x, correct? So let's go to positive 30 degrees, let's go down to -30 degrees. That puts me right here, correct? Yeah. So tangent of -30 degrees is on my y value, which is -1/2, divided by my x value, which is square root of 3 over 2. So dividing fractions is easy as pi. We flip the second and we multiply. So we're going to have -1 over the square root of 3, which we would rationalize the denominator, and we should be able to quickly see this is negative square root of 3 over 3. So the unit circle makes it really fast and easy to evaluate a lot of trig functions and find the exact value. Okay. So this is how we fill out my unit circle. Ready? Here we go. So you'll do it, then you'll take another blank one, you'll try it by yourself. So this is kind of how I think through it. There's lots of ways you can think through it. The first thing I do on a unit circle is I go in and fill in my zeros and ones. So this is point over 1 of 0, correct? I fill these in first. I'm showing you my tricks to filling this in. Over 0 up 1, go. -1 of 0 and 0, -1. I fill those in first. Then I focus in on quadrant 1. This is 0 degrees or 360 degrees, correct? Okay, so then these are special right triangles. So up, the first one will be a 30. The next one will be 45. And the next one will be 60. And this one will be 90 degrees. Okay. Now notice a quick relationship here. We went up 30. So we went up 30. Then we added 15, add 30. Does everybody see? So we could take 90 and add 30, add 15, add 15, add 30. So we can figure out all of these angles right here. So once again, you'll just, you know what I mean? You can just notice these things. You can think of it so many different ways. So this is 100, and so I took 90, added 30, 120, add 15, right? 135, add 15, 150, and then add 30, and that's at 180. I mean, pretty easy. Then I add 30, add 15, add 15, add 30. So same idea. So this is 210, 225, 240, and 270. Same thing, add 30, add 15, add 15, add 30. So we would have 300, 315, and 330, and then I'm back, add 30 at 360. So that's how I fill in the angles. Now, I like to also fill in, so then I go through and fill in them in radians now. So that's in degrees. We would also like them in radians, the physical distance, the length of the arc. So remember, you could do this by hand. The first quadrant you could just do by hand, but these ones you'll get memorized pretty quick. So remember, by hand you could say 30 degrees convert to radians. So we multiply by pi over 180. So that simplifies to be 1/6, correct? Yeah. So this is pi 6. You could do the same thing here. We get pi 4ths, and then pi 3rds, and then pi halves. And then these ones are easy. So this is 2 pi, this is pi halves, this is pi, right? Everybody, we good? And then I think of it like this. I go, this is 1 pi halves, this is 2 pi halves, here's 3 pi halves. Or you could literally just convert 270 like we did up here. But I like to just find little tricks to help me. So this is 1 pi 6. We went that distance. Going that distance again would be putting us here. Here's 2 pi 6, right? So I'm just doing a little trick so that I don't have to convert all of these by this way. So going this distance was going pi 6, right? That's 1 pi 6. So going that same distance would put us at 2 pi 6, which is right here at pi 3rds, right? 2 pi 6 simplifies to be pi 3rds. Does everybody see? And then, so that was 2 pi 6, and then here's 3 pi 6, right? 4 pi 6. So 4 pi 6 is 2 pi 3rds. 5 pi 6 would be here, wouldn't it? So 5 pi 6, and once again, let's say you don't like that, just take 150, divide by 180, math, enter, enter. You know what I mean? Whatever's quickest for you. We could convert it just using this method, right? Okay, so anyways, so then once again, I just go through and I like find things. So then this would be 6 pi 6, 7 pi 6, 8 pi 6, which simplifies to be 4 pi 3rds, 9 pi 6, which simplifies to be 3 pi halves. Then here would put us at, yep, 10 pi 6, which simplifies to be 5 pi 3rds. Or you could just convert. You could take your calculator, 300 divided by 180, math, enter, enter, and so on. And then this would be 11 pi 6. However you want to do it. So then once again, if this is 1 pi 4th, this will be 2 pi 4th, this will be 3 pi 4th. Or you could just convert it. 4 pi 4th, here would be 5 pi 4th. Here would be 6 pi 4th, and here's 7 pi 4th. Yep. So I'm just looking and seeing, okay, now I filled it all in radians. Now this next part, we could think about our right triangles, or this is a little trick I use, instead of even thinking about that. So this is how I go in this order. It's just a little trick I use, but you can do it however you want. So I start with 0 and I count up. This is just a little trick. So this is technically, we could call that's the square root of 0 over 2, which is 0. This would be the square root of 1 over 2. And then it'll count up the square root of 2 over 2. This will be the square root of 3 over 2. So I'm filling in my y values. And this is the square root of 4 over 2. Now, doesn't square root of 4 over 2 become 2 over 2? Which is 1. And then square root of 0 over 2 was 0. And then square root of 1 over 2 is just 1/2. So that's just a trick I use. Then I start at 0 and I count up like I did over there. So this is square root of 0 over 2. This is the square root of 1 over 2. Square root of 2 over 2. Square root of 3 over 2. And square root of 4 over 2 would put us at 2 over 2, which is 1. And then that's all I need. And then the rest of the quadrants, now I can fill in. So I'll show you what I mean by that. Yep, perfect. Yep, so this is good. So like, look guys, this is up 30 degrees from here. So this point right here is up 30 degrees. This will be the same as those. And then we'll just change, one will be negative, one will be positive. You'll see what I mean. So this will be the same as that. So square root of 3 over 2, and then 1/2. Everybody feeling good? This will be square root of 2 over 2. This is square root of 2 over 2. This is here, and here will be the same point, 1/2, and square root of 3 over 2. The only difference is my x values here will be in the negative, correct? So now I'll just go through and change all my x values to be negative. Does everybody see the trick? So this is down 30, so this is going to be the same point as up 30. So we'll have square root of 3 over 2 and 1/2. This is the square root of 2 over 2, square root of 2 over 2. And this is 1/2 square roots, 1/2 and square root of 3 over 2. And then we would say these are x and y values negative. Negative, 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 negative. And then these ones, same thing. This is down 30, so it'll be the same as that. Square root of 3 over 2 and 1/2 and square root of 2 over 2, square root of 2 over 2, and so on. 1/2 and square root of 3 over 2. Then I say to myself, the x's are positive, my y's are negative. Y's are only negative here. And now I filled in my unit circle, and now if I say to you, find the sine of 210 degrees, you go to 210 degrees, sine is y, your answer is negative 1/2. It's that quick. So filling in the unit circle is awesome. When you get to ACT, I literally will draw down quadrant 1, and then I just can use that if I think about it, or you could draw in the whole unit circle real quick. So next time we're having a quiz, I'll hand you a blank one, you have to fill it in. So before lunch, let's just all practice doing that. Give yourself a blank one, see if you can fill it in. Try to learn the trick. I have the unit circle up here just to refer back to. So everybody, here we go. It says, evaluate, this is exactly like the book, like your homework. It says, evaluate the 6 trig functions at each real number. So it says that theta equals pi 6. So everybody locate pi 6. Go, locate it. I'm going to locate it up here. Pi 6, boom, it's that xy point right there. Let's answer very quickly now. Sine, cosine, tangent, and all of the trig functions. What's sine? Isn't sine y? So sine of pi 6 is 1/2. Questions? Ask them if you do. Okay, cosine of pi 6 is square root of 3 over 2. Very good. Tangent of theta is y divided by x, correct? Cosine over sine, correct? So that would be this divided by this, which would simplify to be, let's just draw it then. So square root of 3 divided by 2 divided by 1/2, correct? Dividing fractions is easy as pi. You flip the second and you. So that would be 2 over 1. So the 2's cancel out. So square root of 3 would be our answer. Cosecant. Cosecant is the reciprocal of sine. So what would the answer be? 2. Secant of pi 6 would be the reciprocal of that. So that's 2 over the root of 3, which rationalizes the denominator would be 2 roots of 3 over 3, correct? Yes. And then cotangent is the reciprocal of tangent, which is 1 over root 3, which rationalizes to be the root of 3 over 3. Everybody feeling pretty good about these? Pretty easy, right? Okay, let's be careful though. So theta equals 0 degrees. So locate, now I'm going to erase, go to your unit circle, go to 0 degrees, or 0 radians, and that would be this xy point. Here we go. So remember, cosine is x, sine is y. So sine of theta is 0. Cosine of theta is, tangent of theta is y over x, which is 1 over 0. Is that okay to divide by 0? So y. Oh, you're right. 0 over 1. You're right. Cosine is x, sine is y. So it's 1 over 0. Which it, what? Why is it 0? Oh, duh. We did that, I did that on the other one. Well, isn't it? It's y divided by, oh, y is sine. Duh. Crapola! This video sucks now. So all this was wrong. Tangent, freak nasty. Okay, 1/2 divided by the square root of 3 over 2. That would be, okay, so we just switched those two, correct? Okay, is anybody confused? All because of me. Yeah, it's in the video. Okay, so the tangent was really this, square root of 3 over 3, and the cotangent was really root 3, geez. Okay, cosecant is the reciprocal of that. So that's technically 0 divided by 1, correct? So cosecant would be 1 divided by 0, so it's undefined, correct? Yep, and then secant would be 1, correct? 1 over 1? Isn't 1 the same thing as 1 over 1? So secant is just 1. Cotangent is, so our answer here was 0. So which was 0 over 1, so that'd be 1 over 0, which is also undefined. Can't divide by 0. Okay, questions, pretty easy. Okay, let's word it. Okay, you guys get it. I don't need to do this, right? You do know that negative pi thirds would be going down to 11 pi 6. Does everybody, oh wait, 11? No, it'd be going down to 5 pi thirds. How did I find that so quickly? I went up 1, 2, 3, so then the negative would be down 1, 2, 3. Or technically I found the coterminal angle. Okay. What if I read it differently like this? What is the sign of negative 15 pi thirds? Everybody look, this one is not on the unit circle right now. So couldn't we find the coterminal angle that will fall in our unit circle that will land in the same spot? So I'm going to add 2 pi. I'm going to see if that comes out positive. Does it? No. So let's add 2 pi again. So guys, I'm literally taking my calculator and not typing in the pi. I'm doing negative 15 thirds plus 2. That's negative 3. So that would be negative 3 pi. Still not that helpful. I'm going to add 2. That's negative 1, add 2. So, and that's 1. So I added 2 pi plus 2 pi. Was that a lunch bell? Okay. With this one. So it says, what is the sign of negative 15 pi thirds? I literally added. So the thing is I don't like dealing with negatives ever. Like I always like to deal with positive, and negative pi thirds is somewhere on the unit circle, but trying to figure out it would be hard. So I found the coterminal angle, which would fall in the same spot as negative 15 pi thirds, which, like Amelia said, that's negative 15 pi thirds is negative 5 pi. So does everybody understand that? Instead of me figuring out where negative 5 pi was, I did the coterminal angle. I added 2 pi, it was still negative. So negative 5 pi plus 2 pi is negative 3 pi, correct? And then I added 2 pi again, and then I got negative 1 pi, which is right there, but I added 2 pi again and got pi. So then I know that negative 5 pi is the same thing as pi. So now I can answer. The sine is y, so my answer would be 0, right? So you can use coterminal angles to help you out. Okay, so what's the cosine of negative 90 degrees? Good. Cosine of negative 90 degrees is 0. What is the sine of 225? Negative square root of 2 over 2. Is everybody seeing where those are? Pretty easy, right? You don't? So let me show you. Find positive 225 is right there. We have these x, y points. Cosine is x and sine is y. So we know that the sine of 225, the exact answer would be the square root of 2 over 2, negative. Okay, So let's just quickly talk about the domain, and then it talks somewhat about period. We're not going to get into that really today. So domain, think about domain of the unit circle. What's my radius, everybody? 1. This is literally just a zoomed in circle in on 1, so the radius of 1. This is over 1. This is the radius of 1, 1, 1. Okay, perfect. So if I said to you what's the domain, it says what are the possible x values, correct? Our x value is bouncing between -1 and 1. So our domain is -1, x values are greater than greater than or equal to -1, but less than or equal to 1. They're bouncing between -1 and 1. So isn't it true to say that -1 and x is sine values? So sine of theta is between -1 and 1. Correct? Isn't x, our sine values are going to be between -1 and 1. Everybody good? Now our range is y values. Y is still bouncing between -1 and 1. So our cosine values are bouncing between, did I say domain? Freak, why can't I need to start using my head instead of just like kind of being zoned out up here. Thank you. Cosine is x. Yeah, I might have to record this again B-Day. I'm probably pretty sure I'm gonna. Sine of theta is considered equal to 1. Yes. Well, maybe I will because I've already got this far. I see why not, right? Okay, so period basically it's saying, so think about guys, they give you this when talking about period, but we're not going to get into it. It just makes sense. So sine of theta will be equal to, so all of our sine values of any angle will be equal to the value plus 2 pi, correct? We add a circle, we add back up at the same spot, correct? Can we add 2 pi as many times as we want and we'll end up back at the same spot? So that's why they have sine of theta will be equal to sine of theta plus 2 pi n, where n is the number of times you're adding 2 pi. So we can start at, for example, we can start at pi halves and we can add 2 pi, we can add it again, and won't our sine value always be the same? Our y value is always going to be the same. So this is making sense. So cosine of theta equals cosine of theta plus 2 pi n. That just means, like for example, if we're looking at 5 pi 6, cosine is x. We could add 2 pi and end it back there. We could add 2 pi and add it back there. And no matter what, our cosine of that angle will be the same. So basically, we're just using coterminal angles and saying that coterminal angles land in the same spot. So cosine and sine will be the same. Okay, so number 30 in the book says find cosine of 5 pi. So you could actually think about this. Isn't the whole thing 2 pi's? So we could go around again. We'd be at 4 pi here, correct? Yeah. So then adding another half of a circle would be adding pi. So that would put us right here at 5 pi's here, correct? That's the same thing as doing 5 pi minus 2 pi minus 2 pi, correct? Which is pi. So it's just finding the coterminal angle, or you can think about it around the circle that many times. I think it's just easier to do that. So cosine of 5 pi is -1. Questions on that? Pretty easy. Super simple. Okay, even in odd functions, I'm going to hopefully make sense of this to you. This is the hard part. Not really, but if you can see it. So even in odd functions, remember an even function means if we plug in a negative into the function and we simplify it, it's considered even if it comes out f of x. So if you plug in negative x and you simplify and get the same thing you originally had, it's considered even. Does everybody understand? Remember that, back to that. We did that in like our first unit. And then odd functions, if you plug in a negative into the function, it will be considered odd if you simplify it and get the negative function, -1 times the function. That's considered an odd function. So an even function for trig functions are cosine. Cosine is even. And so secant is the reciprocal. So if cosine's even, then secant is even. And then odd functions will be sine, cosecant, because the reciprocal is sine. If sine's odd, the reciprocal is odd. And tangent is odd as well. And I'm going to show you why that is. So if tangent's odd, then cotangent will also be odd. So I'm going to show you why that makes sense once you get that down. Evens, cosine is even. And secant, so all you have to remember is even is cosine, odd is sine and tangent, so then the reciprocals are also that, even and odd. Do you get what I'm saying? I'll show you why, and then you'll say, oh yeah, that does make sense of why it's even, cosine's even. So get that down, then I'll show you. Okay, let's consider, for example, cosine of 30 degrees. Cosine of 30 degrees. What do we get? So cosine of 30 degrees is root 3 over 2, correct? Now let's plug in negative into our function, so that'd be cosine of negative 30 degrees. So we're testing if it's even or odd. So I'm plugging a negative into my function. So cosine of negative 30 would be, nope. What is cosine of negative, isn't this negative 30? It's square root of 3 over 2. So when we plugged in a negative, we got the same function. Does everybody see why it's even? Yeah? Okay, let's do sine just for fun. So here we go. So we plug in, let's consider sine of 30 degrees. Sine of 30 is 1/2. Now let's see if it's even or odd by plugging in a negative. So we're going to now consider sine of negative 30 degrees, which is negative 1/2. So when we plugged in a negative, we got out the -1 times the original function. So that makes it off. Everybody feeling good? Okay. Awesome. So let's answer these questions. They're out of the book, and they're similar to your homework one. So it says, if we have sine of negative t equals 3 over 8, what's sine of positive t? So think about it, guys. Is sine even or odd? Sine is odd. So we know the fact is, if you plug in a negative and it's odd, it'll come out opposite, correct? -1 times the original function. So what would the answer be? If this is 3/8, what would the answer be? Negative 3/8. Does that make sense? Do I need to go into further details if I can? We plug in a negative, we're going to get the opposite. So negative. All right, so then cosecant would be flip 8 over 3, correct? Cosecant is the reciprocal of sine, and it will be negative because it's positive t. Right. But we put a negative because this was a negative. Sine of t is. Yeah. Okay. Everybody good? Okay, there was the rule. So I'm just keeping it a little bit. So here's my rule. So cosine of positive t equals -3/4. If that's true, then if we plug in negative t, what will we get? Yep, so we should get out the same thing, correct? This is saying, so cosine, if we plug in a negative, we get out the same function, correct? So here's our original, we plugged in a negative, we're going to get out the same function. Does everybody understand? Okay, so then secant of negative t, secant is just the reciprocal of cosine, so that'd be -4/3. Yes. Hopefully that helps with the homework. Okay. Okay, now this is the last thing, and then the rest of the time is yours to get as much homework done as possible. So we can use our calculators. So understand something, guys. The reason we have the unit circle is so that we can find exact values of sine and cosine and tangent. However, it is necessary sometimes to not find the exact value, and the decimal answer is okay. So let's look how to type it into our calculator. If I said to you, I don't need an exact value, anytime you need an exact value, you use the unit circle. But we're going to use our calculators to find the approximate answer of sine of 2/3. Now, because we're typing in something in radians, go to mode and change your calculator to radians. That's really, really important. It's going to still give you an answer if you have it in degree mode. It's just going to be wrong. It's not going to be in the right form. Yeah. So everybody go to mode. Then go to, instead of degrees, put it in radians. Now you can just type into your calculator sine of 2/3. And you get 0.866. Everybody good with that? So then think about it. Isn't cosecant 1 divided by that? So just do 1 divided by the second answer. So just type that into your calculator. 1.15. Very good. And now notice this 1.5 is also considered in radians. It's the pi part multiplied out already. So that would need to be in radian mode. So Cotangent. Notice how your calculator doesn't have cotangent? We know that this is really 1 over tangent of 1.5, correct? So just type that in. Yes. That's 1 over sine. So we just typed into our calculator 1 divided by the sine of 2 pi thirds. As long as your calculator's in radian mode. What did we get for this? 0.07. Sweet. All right, now this one is in degrees, so we would need our calculator in degree mode. So you'd say cosine of 30 degrees, but your calculator would need to be in degree mode since you're putting it in by a degree. 0.866.
Wait, is it? What's that?
Yes.
Oh, it is.
Yeah, it is. That's the inverse. Yeah, you could. True. Is it the same? Isn't it the same?
No, it isn't.
Says error.
Error, no.
Did you have your calculator in the wrong mode? I'll have to think about that for a second. Right. Okay. Wait, no. I got the same answer. Oh, you did? Oh. Oh, yeah. No. Yeah. Okay. Okay. So are we good with this? Secant is 1 over cosine, correct? So you just type in 1 divided by cosine of 30 degrees, and then you'd make sure your calculator's in degree mode. That's that? That's not what other people got. Was your calculator in degree mode? Because if we're typing in a degree, it needs to be in degree mode. Okay. That's okay.
I got 1.1.
That's what I got.
1.15. Got it. Cool. Sweet. We're all good. Everybody's good? Okay, awesome. So this is your homework assignment. Page 299, 1 through 15 odds, 25 through 51 odds. That's it.